Fera Science is the national reference laboratory for plant health in England and Wales. We are a government-private partnership organisation. We are 25% government-owned, 75% commercial. And we do all of the import-export regulatory testing, all the inland surveillance testing, but we also underpin that with research on both improvements to detection and diagnostic technologies, but also epidemiology to better understand how to control emerging outbreaks and things like that. And we work across the broad range from quarantine, regulated non-quarantine pathogens through to what we call the quality pests. So things, the everyday, the native pests that still cause a problem for growers. I've been a virologist for 28 years. And I started in certification schemes working in potato, and then I moved into quarantine pathogens, and I've been doing that since 2008, so nearly 20 years doing that. I think for me, if we take a step back from that question, the big revolution has been the move from targeted diagnostic technologies, so things like PCR and ELISA, to the non-targeted technologies, so thinking about things like high-throughput sequencing and how that's being applied, and getting that out of the research lab and into frontline diagnostic technology. And we're still at the very front end of that. So I think in the near future, the much broader use of that technology and how we can apply it in everyday diagnostics becomes really interesting and a really interesting place to develop and help people get through some of the nerves about using that kind of technology. The fear of what if you find something new and unusual. And well, for me, that's part of the reason for using that technology. And as we go beyond that, we then have to think about the use of things like AI, large language models, deep learning, whatever we want to call it, where we can then look at the huge data sets that we're generating in terms of genomic data, in terms of meteorological data, scientific data, and how we can then integrate all of that together to better model what's going on and predict what might happen in the future. I think anything that focuses down interest in a specific area, that you can then work on both the specific problem and the principles around the problem, becomes a really useful thing to try and develop. And so you have both the direct scientific developments that come out of that, better detection technologies, better understanding of the pests and pathogens, but you also have the network building that comes from that, the better understanding of how different researchers and research communities operate. And so both of those things together better arm you for future outbreaks to immediately call the right people to get the kind of development you need to deal with the next thing that comes along.